morning, selamat pagi. Wilujeng Sumpi. I'm originally from this city, so I speak the local language actually. So today I'm going to talk about Indonesian e-vehicles. Is it a potential? Or if it's really the potentials, where the potential is. Yeah? This is basically a common situations that we are seeing on daily basis in many countries. I was spending like 17 years in Europe, in the Netherlands for 7 years, and in Sweden for 10 years. And even in those countries, we were seeing this kind of situations on daily basis when we were commuting to office. And apparently I was not the only one, that people started protesting against such pollutions, that this, for example, a protest demonstrations showing the number of casualties because of the pollution in transportations. And basically here we are talking about vehicles that based on fossil fuels. In recent years, this guy, Elon Musk, came with an idea of these electric vehicles. Actually, electric vehicles is not a new technology. I mean, we are all aware that in the 50s, even 40s, the electric vehicles had been actually researched and developed by people. But what's different with this particular person was that he managed basically to bring electric vehicles into market. We could see like in the earlier stage, in the early 2000s, when he developed his electric cars, it cost like almost $100,000 per car. And we could easily understand that such price was actually a price of a luxury car or a luxurious sport cars. But imagine, within just around 10 years, he managed to go down with a normal car of $30,000. And $30,000 is not cheap, but certainly this is not a very expensive car either. I mean, you can see many cars in Indonesia, which is medium-sized cars, are actually around this price. So this is the disruptive he has brought to the market, that he managed to bring things into the market. So it's not only the disruptive of technology, but the diffusion of the technology. And if we see these numbers, this is the numbers of superchargers per million inhabitants in 2018, which is beginning of this year. We could see that Scandinavian countries, Norway, Sweden, and Denmark, has like high numbers of superchargers per million inhabitants, and followed by other countries, mostly in Europe and United States, and also 2 countries in Asia, China and Japan. So it means like they start figuring out that to have an electric vehicle, so they have a fast charging that can charge the cars in considerable time. So you can imagine now if you go to pump stations, you stay for like 5-10 minutes and you have enough gasoline to drive for like up to hundreds of kilometers. And this is basically the device to do so with electric vehicles. So you go to the fast charging stations, you have enough energy, electricity to drive for another 10 or even up to 100 kilometers. And the drive, we listened before that the drive is also from society, not only from technologies. And this is actually the highways somewhere in France, maybe nearby Paris, where due to the pollution, people start having limitation in the speed, because you know cars, the combustion engine cars, they will emit more pollution to air when the speed is higher. So there in a highway, you put a limitation for this car speed, actually to limit the pollution to the air. And it starts by having many cities, especially big city metropoles, they start introducing discussion or regulations to basically ban diesel-based or fossil fuel-based cars in the cities. And of course, automakers start responding. Volkswagen, for example, in 2016, they announced that they would try to bring tens of electric vehicles to the market by 2025. And they have millions of units targeted to be sold in 2025, which is 25% of total sales. And Daimler, Mercedes-Benz, for example, announced that they would introduce up to 10 new electric vehicles to the market by 2022. Volvo's, they already made a decision that starting from 2019, they will only produce electric vehicles or hybrid electric vehicles. And BMW would have a number of electric vehicles, models, and a number of hybrids on the road by 2025, which actually, in correlations with these countries, they start banning gasoline or diesel-based vehicles, cars especially, that you can see countries like in Europe, Norway, Britain, France, the Netherlands, they start announcing when they will completely ban gasoline and diesel-based cars or vehicles. Netherlands, for example, going to emission-free cars in 2030. And they start with new vehicle sales anyway. But most importantly, in my personal opinion, is that China, the biggest producer and the biggest market, they also announced that in the near future, they will go for gasoline and diesel. And they go with the new productions and hundreds of models. And this is actually a very smart, in my opinion, decisions, because in diesel and gasoline-based vehicles or cars, China has been maybe behind the pioneer in auto manufacturers like the Germans, the Japanese, the US companies, and European in general. So actually, this is, in my opinion, a smart move that they are making a leapfrog to go on the top of gasoline or diesel-based vehicles into electric cars. And seeing all these big countries are there, and not to forget also India, which start producing also a lot of cars and have a lot of big market. So it's a global phenomenon that it seems has no break. So either we join this phenomenon or we are like behind. So as we saw how China is really leading in these technologies, that this news from October, end of October, saying that China is crushing Europe's electric car dreams, which is actually due to the strategic that the Chinese automakers has made to focus on the battery technologies. So you probably all understand that the main components of electric vehicles are the electric motors, the power electronics, and mainly the batteries. And the Chinese companies, they are really strategically targeting to control and to master these batteries technologies, which has been somehow not really under the radar of the European companies, understandably, because they probably had at the time a good market and business in the classical gasoline and diesel-based vehicles. So then the Chinese companies are really progressing well in these electric vehicles. It was announced last month in November 16, 2018, that Volkswagen now start spend 50 billion on electric cars offensively, which is basically to catch up this batteries technology that the Chinese companies have been so far managed to master this. How about Indonesia? We are actually having a good hope. I mean, this is electric cars made by students in Telkom universities, and it won in Indonesian competition in two categories, the accelerations and the brake, which is equally important. You can imagine if you only make a fast car without ability to brake it, then it's useless. So this is a good car made by the students. So it means like even we in Indonesia, we actually are looking into this direction, and this could be like a good opportunities for us that has been like dreaming in many years to develop our own, let's say, brand for cars or vehicles. And proudly we can say that Delft University has started the small step toward that things. So when we are talking about Indonesia, I would directly say here that, in my opinion, what will be our best opportunities is actually electric bike. So this is the photo taken last year from PLN, which is Indonesian Utilities, in Jakarta office in Gambir, where they had bought at the time up to 50 motorbikes with running with electricity. So it's electric motorbike. And why electric bike is particularly good for Indonesia in this e-vehicles phenomenon. First of all, if you are in traffic in Indonesia, especially in the capital in Jakarta, this is a not so seldom situation that you are facing on a daily basis. And imagine you are here. It's not nice. I had that experience. You go with this online project and you end up with this. It's really not nice. And if you see Jakarta particularly, it is true that you have a lot of cars, but you can see that there are even more motorbikes. And it's not only for private. If you go for these startups, these unicorn, many of you maybe have heard about this unicorn in Indonesia, which is one of the biggest, is this online motorbike taxi with these green jackets. So this is like a normal situation that you see around a station, this KRL or this train commuter line station in Jakarta. So you can imagine a lot of motorbikes, a lot of taxis, a lot of people waiting with these typical maskers, either white or green or sometimes purple. So this is a daily situation that you are seeing in cities like in Indonesia, like in Jakarta. And it's actually supported by numbers. Only in 2016, there are more than 25 million cars in Indonesia. And when we are saying cars, it basically includes all vehicles with 4 wheels or more. So include buses, trucks, trailers, etc. And there are more than 100 million motorbikes in Indonesia. So this is the number of motorbikes, this is the number of cars. And why people in Indonesia are after motorbikes? Quite simple. First of all, it's low cost with around $1,000 or 50 million rupiah. You can get one motorbike, which is much lower cost compared to cars which started more than 100 million rupiah, so over 10 times more expensive. And many credit facilities are available to support this ownership of motorbike. And also it has a low operational cost. We have made calculations, for example, that for a normal motorbike, you can get 5 kilometers distance for every liter of gasoline. So it means like around 100,000 rupiah operational cost per month. But this is not the only one. Actually, most of commuting in Indonesia is made with only 1 or 2 persons. So either you are the worker or the students going to school or office with the vehicle, or you are taking your kid to school. But most of the activities is done by one or taking 1 or 2 persons. And as you can see here, we can agree or not, but still motorbike is traffic jam flexible. That it can go around and flexibly enough to to avoid the congestions. So these have been the major factors for classical petrol-based vehicles, which is motorbikes, which is very popular in Indonesia. So what e-motorbike offers? First of all, it has a similar speed, practicalities, and today is also similar distance to the classical petrol-based bike. So basically, it offers exactly the same as the petrol-based motorbikes, except the batteries, but we will discuss about it later. So the price today for electric bikes in Indonesia, you can get it for like around 20 million rupiahs, while the batteries cost is around 5 to 7 million rupiahs, so 1/3 of the price for the motorbike. But anyway, the first investment can be made similarly as the petrol-based motorbikes. And on the top of that, it's actually environmentally friendly, because during the operation, it produces no noise, no significant noise, and no emission. So it means like when they are commuting around the cities, you feel the fresh, basically less pollution. And it can be even better, for example, if the electricity supplying the electric bikes is also produced using renewable energy. But overall, during the operations, no noise, no emissions, so it provides lifestyles, and it can be actually potentially savings in long term. It has still many challenges. So first of all is the economy. The batteries is still expensive. You probably have experienced batteries for your laptops that cannot survive longer than, I don't know, 2-3 years. And in these electric vehicles, electric motorbike, the batteries is like 25% of the overall cost. And if you have to replace that every 2-3 years, you can imagine how big will be your investment. So this is the challenges to overcome. And credit facilities, the financial institutions are not familiar yet with providing credits to the purchasing of electric motorbikes or electric cars in general. How about the collaterals and so on, and especially about the batteries. And that's why now research, or not really research in terms of technology only, but also research in terms of business development, they are looking into possibilities that the batteries is not necessarily be bought by the bikers, by the owners of the electric bike, but it can be a rental instead. So here we are in Indonesia, for example, familiar with this propane tank, this LPG, where we are buying that to cook. So now the research or the business development is going in that direction. But once it's worked, I personally believe this will be a game changer, one of the first game changer for the diffusion of electric bike in Indonesia. The second challenge is the infrastructure, because you can imagine when we are having a classical petrol-based motorbike, we go to the pump stations and within minutes we have it full and we can ride the bike in significant distance. So it's still a challenge to provide similar infrastructure for electric vehicles where we can offer a fast charging stations to make the electric vehicle be charged in a short time to cover a significant distance. And the good news is, like 2-3 days ago, Pertamina, which is an Indonesian oil company, they start looking into this option, and I think 3 days ago, PLN start this fast charging in pilot. The best with electric vehicles compared to the petrol-based motorbike with actually many possibilities to charge the batteries. So we can use fast charging, that is number one, but we can also actually swap the batteries, which is more practical for electric bike, since the batteries is maybe only a few kilograms, which is still easy to handle by one person, even a lady, or a teenagers, for example. Or to charge it slowly at home or at office. So this is actually a better offers given by electric motorbikes compared to gasoline motorbikes. Gasoline motorbikes, you can only practically fill the tank in the gas stations. Electric motorbike, you can have the charging in fast charging stations, so similar to gas station. To battery swapping, that can be in anywhere, any kiosk, like Indomart, Alfamart, or any kiosk, possibly, and at home or at office. The third challenge is after sales. So how to fix or make some maintenance of your bikes. How about the spare parts? How about the reselling price when you stop using it and want to sell it? The fourth challenge is in the technology. Of course, the design needs to look good and intuitive, easy to use like a normal motorbike. The batteries to be cheaper, lower in cost, and longer in life cycles, lifetime, cost, and Internet of Things, which I would have a slide or two to discuss about that. And then the last, not least, is the regulations. How to compare these electric vehicles to, for example, the engine capacity when you have these permits and all the regulations oblige to these vehicles. So when we talk about electric motorbike, I would like also to introduce to you here by showing that e-motorbike is actually not completely new either. Now we are talking about Industrial 4.0. So I would rather say that even electric motorbikes, we can also say, is following more or less this step. If you see electric motorbike 1.0, if you go to, for example, Taman Lalu Lintas, which is a kid playground in Bandung in the city, we have been working with this electric motorbike since maybe 80s when I was a kid. So why it's 1.0? In my definitions, easy, because the batteries inside need to be taken out completely, and then you have to charge it manually. So this is electric motorbike 1.0. And then how about 2.0 then? If it's 2.0, that also has been around for many years, where basically it's a electric motorbike where you can simply charge it at home or at office with a 220 volt and a couple of amps. So it means it probably can be charged fully in a couple of hours, which could be a problem, but could be not if you are using the motorbike to commute from home to office. So you can, for example, charge slowly at home, and then you get enough to bring you to office. You charge it back at office. You work for like 8-9 hours, and then you're going back home with this e-motorbike. So the technology is there, it's 2.0. And it can be charged in your garage. And again, the beauty of this electric motorbike, even if it's slow charging, we can assume with the same outlet, electricity outlet at home, it will be charged faster than a car. Because the battery's capacity in kilowatt hours is smaller. So it's more practical in many senses. So how about e-motorbike 3.0 then? So we define this as first the motorbike that can be charged using a facility of fast charging stations. So instead of having a slow charging in hours, we can have like some couple of minutes or few minutes of charging that can bring the motorbike to transport us in 10 of kilometers, enough to bring us to the next pump stations, and we only need a couple of minutes to charge our motorbike. So the first is fast charging, and today's technology, they can charge motorbike literally in few minutes, especially motorbike. So even with cars, it's not like hours we are talking, it's minutes. And even with motorbikes, it's more possible to have it fully charged in minutes. And the second generation of this 3.0 e-motorbike is the battery swapping stations, where in this case, you are swapping the batteries in the station, battery swapping stations. The beauty of this is actually you don't need to have like a typical, pump stations, but you can have a standard kiosk, like we are very familiar in Indonesia with a lot of kiosks, where these kiosks are providing batteries to be swapped with the motorbike riders. So they simply come to a battery swapping stations, they bring the empty batteries, they put it there, and they bring the full batteries to their motorbikes. Very simple and even faster than the fast charging. So this is 3.0. And again, we understand why electric vehicles is more potential in this case compared to cars, again because of the battery size. So lifting these batteries for motorbikes, with its few kilowatt hours in size, is practical. We can do it without heavy, too heavy materials. But imagine with cars, we may need a robotics helper to exchange the batteries. So it means the infrastructure will be much more expensive. So how about motorbike 4.0? This is actually I would like to bring, or just to give some ideas, because I think this topic is still open, and this is actually interesting for research centers or researchers that basically dealing with digital technology as well, like telecom universities. So we are talking about e-motorbike 4.0. So I probably will go back a little bit on electricity 4.0, which basically a classical power systems, which are having some big power plants and then transmitting powers to customers, which are residential, commercial, or factories. But in electricity 4.0, fast forward, that's basically an inclusion of a lot of renewables, large scale in the centralized power plants, but most particularly is this photovoltaics put on the rooftop of buildings that can generate electricity, and therefore electricity can go theoretically to other customers, or even go back to the transmission system going to another area, for example. And on the top of that, the loads is also supported, or they are also having a load which is electric vehicles with a significant energy storage batteries, which is inside the electric vehicles or outside. So why is this significant? Because by having this electric bike 4.0, what is happening is basically a smart mobility, where we are using as much as possible digital technology to support the mobility of our electric vehicles, or in this case, electric motorbike. We know that this electric motorbike has different options to charge. It can be battery swapping, it can be fast charging station or home charging with smart meters. But on the top of that, it must be connected through digital platforms so that we know how the batteries is related to the behavior of the riders. So it's not only giving like a percentage of the batteries, but in a smart way, it gives like every time a real-time information how far you can go with your current batteries, and if you want to go further, where you should charge your motorbikes, or where you should swap the batteries, or is it enough by charging at your office? So there will be interactions, there will be a big data analytic, there will be like artificial intelligence in the big data that will give recommendations on daily basis, on real time to riders that no worries, you can always reach your where you want to go, and you don't need to be worried because you will always get full batteries. So this is 4.0, and having all related. So here, for example, we can track the electron, we can track the distance, and it's only one step further that we can basically track the money. So it means we can charge our motorbike, our vehicles everywhere, and we can always charge and pay through digital means. And why it's good? Because everything will be like in the same platform. And now in Indonesia it's happening. We go using online public transportation, we are paying with the digital means and digital apps. So why it's like potential for Indonesia. This is the data from 2017, from last year. We have more than 260 millions of populations, and we have like half or 50% of the populations is an active internet users. And also they have like even more mobile subscription than the populations. But interestingly, half of these internet users are using smartphone. And that is already one gate that can interface the physical system of electric motorbike and the digital system of the big data analysis. 50%. This is on 2017. Maybe it's higher. And we have also a lot of millennials in the country where they are having new or maybe unique mindset, where mostly of these five mindset is that they are very, community engaged and also like innovations. And most likely again, and also tech addict, of course. So most likely this will be the first customers that embrace these electric vehicles. And going back to the electricity world, we see that this is the data about the solar module prices over 40 years. So in the 80s, the price of a photovoltaic per watt is almost $20 US. And today, if you only talk about the solar module price, it's already less than $1. So 20 times cheaper. And it's only about time before people at their houses will start putting a lot of photovoltaics, or manufacturers per house will also put many of these photovoltaics. So what will be the impact to the utilities? This is still related to electric vehicles. I will explain later why, especially 4.0. So you can imagine when many solar photovoltaics is installed in the rooftop of a building, either household, residential, or commercial buildings, basically what happens is they will pay less electricity bills. Because during the day, especially in commercial building, you can imagine like these hotels, that many activities maybe is happening during the daylight. So it means electricity will be supplied by photovoltaic, so customer will pay less electricity bill monthly. What does it mean? It means the utilization factor of the large power plant will be less, because the big power plant will generate less energy, since now part of the energy is supplied by the photovoltaic. So if you want to still keep the same return of investment of these large power plants, it means you need to increase the electricity price. And when the electricity price is increased, it's even more cheaper to use photovoltaics. And people will use even more photovoltaic. And economic of scale tells if you have more in production, price will go down. So on the PV system, it will be cheaper and cheaper, while in the classical system, it will be more and more expensive. Is it dangerous for utilities? It depends how you see it, but answer could be yes, because of this, reducing revenue and longer return of investment. So, for example, now Indonesia, just a couple of days ago, there was a viral news in WhatsApp saying that in Indonesia, utilities said, yeah, you know, houses in Jakarta, they should not put photovoltaic because we have like excessive electricity. And you understand why? It's because of these virals. So it's from 27 November, so last week. It says like, it's Indonesian, but I will translate it. It says like, according to this ministry regulation and so forth, to put a photovoltaic, you have to get a permission from the utilities and so forth and so forth. There's a clause regulate this because it says that the utilities need to be not, should be able to manage all this electricity which is supplied by the rooftop photovoltaics. So this is an example of formulas given in the regulations, like when you are importing or when we are buying electricity from utilities, we pay 100%, but when we are exporting our electricity from the rooftop, we only get paid 65% of the price. So, what can we do? And first of all, we understand that it's there in place because photovoltaics is producing electricity only during the daylight, of course, and we don't know when the loads are. So it means load could be 24 hours at home, for example. We need electricity for 24 hours, but we're only producing electricity during the daylight, and there may be a case we have a surplus of energy. So this surplus of energy is actually the one that is bought at 65% of the normal price. So how we can avoid that? Actually, by put this surplus energy into an energy storage and not to export it back to the utilities because you only get paid 65%. Batteries is another investment, but if we see it as in the bigger picture of electric motorbike 4.0, the batteries is actually inside the motorbike itself. And when we are having these battery swapping stations, we have a lot of batteries there. And with the big data analysis, we actually can make an optimizations because during the daylight, we can assume that many students or many workers are working or studying. So that is the time when all this photovoltaics electricity generation is supplied to these batteries. And even if you have like battery rental system, it can also stabilize some of this generation, meaning that we are exporting as minimum as possible to the utilities. In a more small platform, for example, now in Indonesia also this courier logistic business is booming, where people are using e-commerce to buy things. They will eventually get the things by courier services. So you can imagine they will be active mostly during daylight. And if they go from one place to the other place, picking the package and going to certain areas, it's actually this type of vehicles could be easily charged during their post-office time, or also because it's not requiring a lot of energy, they can even have the solar panel on the top of their vehicles. And even with the small stuff, you can also steal biking. So basically, even a more potential solutions for logistics in Indonesia. And you can imagine this type of vehicles, if they are going a certain small streets or city centers, it produces no noise and no pollution. So it's basically another benefit to the society. And it's seems maybe a long way from now, but it has happened in Indonesia when this online transportation has practically replaced this older counterpart that despite still having it today, trust me, the system is not changed since I was elementary school and studying in this elementary school next to this hotel. So some 30 years ago, still the same system. So you can imagine, there's no way this can survive, and digital is one of the ways to make the new technology becoming popular. So that's basically conclude my presentation. Thank you very much.
Thank you, Dr. Muhamad Reza. Please kindly stay on the stage as I invite Dean of School of Electrical Engineering, Telkom University, Dr. Bambang Setianugraha, STMT, to present a token of appreciation from the committee.
The second. After that, we have a break. After this, now is a break. Okay, I need to leave after this. Okay. Yeah, so can I get a taxi from the hotel? We already arranged. Okay. How was my presentation? Okay. Okay. You already. No, my presentation, was it okay? Yes. Okay. Very good. You please come over to our place. We will invite you.
Thank you, Dr. Muhamad Reza and Dr. Bambang, and respectfully you may return to your seat.
My grandparents came from India. But you live I'm second generation. In English, in England or something?
Ladies and gentlemen, I sincerely